My name is Kris Sathia, and I am the product manager for STAD Foundation Advanced here at Bentley Systems. So in today's presentation, we are going to be talking about the foundation design options in a license that is known as the Structural Enterprise License. Now, the agenda for the presentation is, first we'll be discussing what is Structural Enterprise. We will look at the products that are offered under Structural Enterprise License. We will look at some of the foundation design components of the Structural Enterprise License. And once that is completed, I will explain some of the workflows that you can use for doing a foundation design using the various products of the Structural Enterprise License. And we'll conclude the presentation with a demonstration of two of the programs that are part of this license. So let's get started. What is Structural Enterprise License? The Structural Enterprise License, or SEL, is a bundled software suite that consists of applications like STAD Pro, the RAM Structural Suite, MicroStrand, RAM Elements, RAM Connection, and many of the other programs that Bentley offers for designing, or for analysis and design of various kinds of structures in the infrastructure realm. So in other words, it is used mainly for the analysis and design of structures that we come across in the day-to-day usage, like, for example, plant structures or bridges or communication towers, buildings, and so on. Now, exactly what is the benefit in using the Structural Enterprise License? It includes complete workflows, which means that you can start with the analysis model. You can complete the analysis, go to the post-processing, view the results, and once you're satisfied with the results, you can take the information into a connection design software or a foundation design software, or you can get the drawings out of these programs. In other words, the complete workflow, which starts from the analysis phase and ends at the final design and drawing phase, is possible through all these different applications that are contained in this enterprise license suite. It allows greater reuse of information, meaning that you don't have to insert the data at various phases. So for example, the analysis model will give you all the information that can be directly used inside the connection design data. That's a seamless transfer of information. Similarly, you can seamlessly take the data from the analysis software and go into the foundation design software. You can use the programs that are contained in this SEL to design a majority of structures that you come across in the infrastructure sector. Like, for example, this diagram here shows you some of the structures that you might find in a cement plant industry, for example. So here you have the finite element model, you have the steel structure model, you have the foundations model using plate elements, and so on. It allows you to use multiple materials. You can have a combination of steel and concrete. You can use several analysis methods, like, for example, if you consider STAD Pro, it has a linear elastic analysis, response spectrum, time history, p-delta, nonlinear. So in other words, depending on the nature of the model, the analysis type requirement might also change, and these programs offer you the flexibility of switching between the various analysis types that are offered by these programs. Now, the products under the SEL, these are the general products that we have. STAD Pro Advanced. In a moment, I'll come to what each of these products do. STAD Foundation Advanced, RCDC and RCDC FE, the RAM Structural System, RAM Concept, RAM Connection, RAM Elements, Microstrand, and Limcon. Now, in order for a better understanding of all these different products, I would recommend that you watch a presentation that was done by my colleagues a couple of weeks ago, and it's available on YouTube. It's called the Introduction to the Structural Enterprise, and it was done by Surajit and Bishwatosh, and this is the address. And once this presentation goes up on our website, you can watch it in peace and get the link in case you want it. Now, among those products, the ones that are used for the superstructure analysis include StatPro, both the standard and the advanced versions of it, RAM Structural System, RAM Elements, and Microstrand. For foundation design, we have RAM Concept, the RAM Foundation component of RAM Structural System, RAM Elements, RCDC FE, and Stat Foundation Advanced. So in this 38-minute session, we are going to be looking at the possibilities for the superstructure plus the foundation analysis and design from amongst a few of these products that I have just listed. Now, what is Stat Foundation Advanced? This is a program that is for the general purpose foundations that you come across in your day-to-day designs that you perform in the office, like the isolated footings, combined footings, pile caps, mat foundations for general and plant type structures such as horizontal and vertical vessel, storage tanks, etc. It offers the ability to optimize the foundation size, meaning that you can ask for it to come up with the most optimum size for an isolated footing or a pile cap or a combined footing. It will perform the reinforced concrete design to a variety of codes like the American, European, Indian. We have the Chinese code coming up shortly, the Euro code, and so on. And it also produces drawings. RCDC is a recently introduced product in the portfolio, in the structural enterprise license portfolio, that is. It is an advanced concrete design software that can be used for the design of not only foundations but also the superstructure components like the beams, columns, walls, slabs. It has extensive capabilities in the areas of plan, elevation, and cross-section drawings, which you can export to AutoCAD or any drawing that can take a DWG or a DXF format. It can produce a bar bending schedule and the bill of quantities. The RCDC FE is another recently introduced program in the Bentley portfolio. It is a slab design software for the reinforced concrete design of a superstructure slab, or rather an elevated floor slab in a building, as well as for the mat foundations of those structures. This too it's a very versatile software in terms of its ability to perform the design of such two-dimensional entities where the reinforcement directions are along the reinforcement is placed in two directions, that is. It has extensive detailing capabilities, meaning that it allows you the flexibility of modifying the bar arrangements in various zones or strips or portions of the slab, depending on where it is that we want the bar arrangement to be the densest versus the rarest. It also has extensive drawing capabilities for reinforced concrete slabs and foundations, and I will show you some of the capabilities of the software as we go along. RAM Concept is another established program in the Bentley portfolio. It is used for, it's a very high-end software that is used for slabs, both normal reinforced concrete slabs as well as post-tension slabs. You can generate the entire slab model. It works in an interoperable fashion with programs like StatPro and RAM Structural System. You can lay out your tendon profiles and perform a time history analysis, a footfall analysis. And in other words, it's a very exhaustive. It has very exhaustive capabilities when it comes to the design of slabs. Okay, so now that we have some of these programs in the portfolio, how is the workflow involved, or what is the workflow involved? So, as I said earlier, we have some programs that are for the superstructure analysis and design, and some programs for the foundation analysis and design. So we start with the model in the superstructure analysis program. So you define your model, define your member properties and the loads and the steel and concrete design parameters and so on. And you analyze the structure in a program such as StatPro, MicroStrand, RAM structural system, and so on. Once the analysis is successfully completed, we transfer the data into the foundation design program like Stat Foundation or RCDC or RCDC FE or RAM concept. And if you wish, you can bring in the load combination results too, or if you wish, you can generate those load combinations as we go along during the foundation design within the foundation design program. So once the foundation, the load combinations for the foundation design are generated, you go on to specify the parameters for the soil, concrete, the reinforcement, etc., and perform the design of the foundation. So this is the workflow in broad terms. So in this presentation, I will show you 4 of those workflows. Workflow number 1, we analyze the superstructure in StatPro, push the support reaction and the column data from StatPro into Stat Foundation Advanced. And when I say push, it is somewhat akin to exporting the data. Alternatively, you can close down StatPro, go home, come back tomorrow, start SFA, and import the reactions from the results of the StatPro analysis. And the results would include the support reactions and the column data from a StatPro model. And once that information comes into Stat Foundation, you then design the foundations in SFA. Now this workflow is quite well known, and there are dozens, if not hundreds, of videos on this workflow available in YouTube and the Bentley Learn channels. So for that reason, I am not going to go into greater detail in this workflow. If anybody wants to know about this in greater detail, please let us know, and we'll be happy to send you the links to those videos. The workflow number 2 involves any superstructure analysis program that I described earlier, MicroStrand, RAM structural system, and so on. From those programs, once the analysis is completed, you push the data into what is called as an ISM repository. The data that goes into the repository includes the support reactions in the column positions, column sizes, and so on. And once the ISM repository is created, we then start a program like Stat Foundation Advanced, import the reactions from that repository, and then design the foundations in Stat Foundation Advanced. So here is a brief demonstration of that workflow. So here is a RAM structural system model. We have, as you can see here, the slab, the column, the beams, and so on. The footings are just a representation right now. We will be eventually designing those foundations in Stat Foundation or in one of the other programs like RCDC FE. So we then go into once the analysis of the model is completed in RAM structural system, we go to the file menu, choose ISM, and do what is called as create an ISM repository. So this will create a file with an extension called .ism.dgn. Next, we then start the program like Stat Foundation, go to the file menu, sync ISM, new from repository, and we choose the ISM file that was created from RAM structural system. So this is how the data looks like once it has been brought into STAT Foundation. So you can see the details of the support reaction in the RAM structural system model being shown on the right-hand side of the screen. And in the graphic area, you have the representation of the various supports. You can now proceed to design the foundations as isolated or combined or pile cap and so on. If you want to create the load combinations, you can do so within SFA. It has got a load combination generator based on various codes like the Euro code, ASC code, and so on. So we generate the service type and ultimate type combinations. And once that is completed, we perform the design. And this is how, this is a sample of one of the footings that has been designed using this workflow. The next workflow involves a direct transfer of data between StatPro and RCDC. This is called a direct link because you can there is a direct communication established between these two programs where StatPro is able to send the information into RCDC and RCDC is able to import the information from a StatPro model. So essentially what we are doing here is we analyze the superstructure in StatPro. We can either push the reactions by launching RCDC from StatPro, or we can start RCDC and import the reactions. And once the data comes in, we will then do the foundation design. And I will demonstrate this workflow to you in just a few minutes. Workflow number 4 involves this recently introduced product called RCDC FE. So once again for this, RCDC FE can presently read your slab design data. Remember, we said that this is a reinforced concrete slab designer program for both superstructure slabs as well as mat foundations. So the basic requirement to use RCDC FE is that the slab has to be modeled using finite elements. So the finite element model of the STAD, let's say, is done in StatPro. We complete the analysis and we start RCDC FE, specify the name of the StatPro model. It brings in the information and then performs a design. And let me just show you some of the screens of RCDC FE. As I said earlier, RCDC FE is a very exhaustive software. So unfortunately, in about 5-10 minutes, it would be rather difficult to demonstrate the software. So we will be doing a demonstration of that program in another session. But let me just quickly show you some of the screens that will give you some understanding of how the program looks like. So here we are importing the data from a StatPro model. Once it is brought in, it looks like this. We have a mat foundation of the slab under something in the order of 25 columns. We have a combined footing which is modeled using plate elements 2 in the top right corner. We have an isolated footing also modeled using plate elements in the top middle zone. So this is an isometric view of the structure laid out in a grid type of fashion. We can specify the settings for performing the design, grade of concrete, grade of steel, and a whole lot of other information, as you can see here. Information that is required for doing a thermal crack analysis, strip data, and so on. Reinforcement settings, minimum and maximum reinforcement limits, bar sizes, the kind of arrangements that you prefer, a mesh at top, mesh at bottom, stirrup data. We have the ability to instruct the program to treat the pedestals as flushed with the top of the mat, or as you can see in this screen, flushed with the bottom of the mat. So this is the bottom of the mat flushing where you can see the pedestals projecting out from the slab. And this is a view of it where the top of the pedestal and the top of the slab are flushed. We can design individual regions. So here, for example, if I want to just give a specific set of data for the isolated footing I was mentioning earlier in the middle right zone, I can do that, where the reinforcement directions are different from that of the rest of the slab. And once we have specified all of the data, you will get a general strip arrangement, which the program will generate on its own. After that, you can control or make modifications to the strip by doing things like merging the strips or splitting strips. You can specify the alter the width of individual strips. You instruct the program to create load combinations in case you want to, or as I said earlier, you can even import the reactions for the various combinations from the StatPro model. Here we are assigning the load types so that the combinations can be generated based on dead plus live or dead plus wind. So this is a screen where you are seeing the assignment of the load types to each load case that has been brought in. So once that is done, you ask the program to execute the design. The first thing that it would tell you is whether there are any elements that have failed the design, so that you can drill into those individual elements and then make the necessary changes to ensure that the element design passes. You get a pattern of the bar layout across the mat, so that later on we can go and make alterations, such as merging different zones. You may not, for example, want 25 different types of arrangements across the width of the slab. You might want to reduce it down to, let's say, 3 or 4, in which case you can merge adjacent regions. You can, excuse me for a minute. So this is another view of the bar arrangement. Excuse me for that background noise. This is another view of the bar layout. You can do sectional cuts, where you can see the section views across various sections. We can manage sections, where you can instruct the program to change the bar arrangement at individual locations on the slab. On our Bentley website, we will make sure that you will be able to watch this presentation. In the meanwhile, here are some of the ways in which you can contact us. We have a toll-free number for tech support for India and China. You can create a service request, or you can access, you can reach us through Bentley communities. If you go to our website, you can see the addresses and contact numbers for many of our offices in Asia. And that concludes my presentation.